So far we've been talking about amounts of energy without actually being able to calculate them. And what we're going to do now is we're going to find a way to calculate different energy stores. This being physics, of course, there's a way to calculate lots of different types of energy. We're just going to focus on two. We're going to focus on gravitational potential energy, sometimes known as GPE or just PE or potential energy. Mainly it's known as GPE, which is just short for gravitational potential energy. So we're going to look at that one, and then we're going to look at kinetic energy, and we're going to look at the factors that affect it and how we can use those factors in an equation to calculate changes in gravitational potential energy. So let's take that one first. Let's say we have a basketball. Now, originally the basketball is sat on the surface of the Earth at point A, just on the floor, and then we raise it up. We raise it up a certain height. We change the height above the surface of the Earth, above the ground, and we take it to point B. Now, because it's moved in a gravitational field, its position has changed. It's gone further away from the Earth. We say that its gravitational potential energy has changed as well. And by increasing the height, by pushing it upwards, we have increased its gravitational potential energy. So an increase in height leads to an increase in gravitational potential energy. So that's one of the factors. What's the other factor? Well, the other factor is the mass of the object. Obviously, it takes more work to lift a heavier object up than a lighter object, which is going to change the value of its energy by more if it's heavier. So the mass of the object is also important. And the third thing that affects it is the strength of the gravitational field. So the pull of gravity on the object. If you imagine lifting a basketball up, if you could, on the surface of Jupiter, then it would be much more difficult. It would take much more work, much more energy. And therefore, the strength of the gravitational field, which we call little g, is also important. So these three factors, the height that you raise it up, the mass of the object, and the strength of the gravitational field, all affect the gravitational potential energy. And if you increase any of those, you will increase the gravitational potential energy, which leads us to the equation. So raising the object above the ground by increasing its height will increase the amount of gravitational potential energy it has. And those three factors will all be multiplied together in order to give you the equation that allows you to calculate gravitational potential energy. And that's it, there it is. So we have the gravitational potential energy in joules, all energies are in joules, is equal to the mass in kilograms times the gravitational field strength, the strength of gravity, in newtons per kilogram, multiplied by the change in height, how much you raise it up by, or even lower it, and that would obviously result in a loss of gravitational potential energy. So these changes in height from, in this case, point A to point B, result actually in changes in gravitational potential energy. So technically, this equation allows you to calculate a change in gravitational potential energy between 2 points in height. Quite often one of them is at the ground, where we say the height is 0. So, and then obviously the change in height would just be equal to the height to which you raise it. Okay, so that's the equation for gravitational potential energy. It's the mass of the object multiplied by the strength of the gravitational field multiplied by the change in height. And usually we just write it down as GPE is equal to mgh. We call it mgh sometimes, so that's one to remember. Mass times gravity times height, mgh, is equal to the gravitational potential energy of the object. And the only other thing to say about that is how strong the gravitational field strength is on the Earth. On the Earth, the gravitational field strength has a value of 9.81 newtons per kilogram, sometimes rounded off to 10, but we're going to try and use its more exact value of 9.81, which basically means if you have a mass of 1 kilogram, it will have a weight of 9.81 newtons. That's basically what that means. Okay, so that's gravitational potential energy. Let's look at our second type of stored energy, and this is kinetic energy. So for kinetic energy, it's the energy stored in an object due to its motion. So if I throw the basketball with a velocity v, that's going to give it kinetic energy. It's going to move, from the ancient Greek word for movement. Okay, so obviously the velocity of the object will affect the kinetic energy. If it's moving faster, it will have more kinetic energy. And so will the mass. More massive objects, heavier objects, travelling at equal speeds to lighter objects will have more kinetic energy. So the two factors that affect the kinetic energy are the mass and the velocity at which it is going. But it's a slightly more complicated relationship than with gravitational potential energy. In fact, and I'm not going to derive this or look at where it comes from, we just need to be able to remember the equation. So in fact, the kinetic energy is equal to a half, which is just 0.5, that's this factor here, multiplied by the mass of the object, multiplied by the square of its velocity. The square of its velocity. So whatever the velocity is, you square it, and then you multiply it by 0.5 times the mass. So in symbols, we have this one here, and the Ke is obviously the kinetic energy. The half is just a half, so that's just 0.5. M is the mass, V is the velocity, and that velocity is always squared. It's just the velocity that's squared, it's not the whole thing. So it's just that one number for the velocity that is squared. So the kinetic energy is equal to half mv squared. And just like with gravitational energy known as mgh, we tend to know kinetic energy as a half mv squared. So half mv squared means kinetic energy, and mgh means gravitational potential energy.